Today we will be discussing colorimetry. What is colorimetry? Colorimetry is the study of heat absorbed or released during a chemical or physical reaction. A colorimeter is a device used to measure heat flow. This is an image of a colorimeter. There is water inside the styrofoam cup with a cover on top containing heat flow. There is a thermometer used to measure the change in temperature. There is also a stirrer used to stir the solution during the reaction. This equation will be very important in calculating colorimetry problems. Q equals mc delta T, or MCAT. Q is the heat the substance gains or loses in joules or kilojoules. M is the mass of the substance in grams. C is the specific heat capacity of the substance. The specific heat capacity is the amount of energy required to raise the temperature of an object 1 Kelvin or 1 degree Celsius. Delta T is the change in temperature. This can be calculated by subtracting the initial temperature from the final temperature. And remember that the amount of heat energy lost or gained is proportional to the temperature change. Now, what does Q mean? A negative Q value indicates an exothermic reaction. This means that the substance is losing heat. Whereas a positive Q value indicates an endothermic reaction. This indicates the substance is gaining heat.
Our first problem is a heated metal problem. Calculate the energy needed to raise the temperature of 60 grams of graphite from 278 kelvins to 324 kelvins. The specific heat of graphite is 0.71 joules per grams Kelvin. First, we have to calculate the delta T, the change in temperature. To do this, we subtract the initial temperature from the final temperature. In this case, we will do 324 kelvins minus 278 kelvins to get a final delta T of 46 kelvins. Now that we calculated delta T, we can use the Q equals mc delta T equation to solve for Q. First, we plug in 60 grams of graphite for the M. Next, we plug in 0.71 joules per grams Kelvin for C because that is the specific heat of graphite. Finally, we plug in 46 kelvins because that is the delta T in this problem. Your Q should equal 1,959.6 joules, but there are three significant figures in this problem from the 60 grams, the 278 kelvins, and the 324 kelvins, so your final answer should actually be 1,960 joules. In this problem, since Q is positive, the reaction is endothermic. This means that heat was gained during the reaction. Our second problem is a solid dissolved in water problem. When a 25.7 gram sample of NaI is dissolved in 80.0 grams of water in a calorimeter, the temperature rises from 20.5 degrees Celsius to 24.4 degrees Celsius. Calculate the value of Q. First, we have to calculate the delta T for this problem. We will do the final temperature minus the initial temperature. This should be 24.4 degrees Celsius minus 20.5 degrees Celsius, giving you a delta T of 3.9 degrees Celsius. Next, we have to calculate the mass for this problem. In this case, since the solid is being dissolved into the water, the masses must be added. The final mass should equal the mass of the water plus the mass of the NaI. This should be 80 grams plus 25.7 grams, giving you a final mass of 105.7 grams. Finally, we plug all our variables into the Q equals mc delta T equation. We have our Q equals 105.7 grams times the specific heat of water, which is 4.184, and we use the specific heat of water because when 25.7 grams of a solid is being dissolved into 80 grams of water, the solution is mostly water. And finally, we multiply that by our delta T, 3.9 degrees Celsius. Your final answer for Q should be 1,724 joules. However, in this problem, there are three significant figures since both temperatures and masses are given with three significant figures. Therefore, your final answer should be 1,720 joules. Once again, in this problem, the Q is positive. This means that the reaction is endothermic and heat is being gained throughout the reaction.
Our third problem is, how many grams of water can be heated from 20 degrees Celsius to 75 degrees Celsius using 12,500 joules? Now, this problem is different from the previous examples because we are finding grams instead of joules. The specific heat of water is 4.184 joules over grams degrees Celsius. Try this problem on your own. Pause the video for more time. First, we have to calculate the temperature change by subtracting the initial temperature from the final temperature. So when we do 75 minus 20, we get 55 degrees Celsius. Next, we use the Q equals mc delta T equation and plug in what we know. We plug in 12,500 joules for Q. Then we can use the variable m to represent the mass we are finding. Then we can plug in C, which is 4.184, which is a specific heat for water. Then we can plug in 55 degrees Celsius for delta T. Finally, we solve for m, which equals 119.6 grams. However, when significant figures are taken into account, our final answer is 120 grams because there is 2 significant figures in the problem. Thank you for watching. I hope you learned something about calorimetry.